All right. So we decided.
I like that too.
We decided that we're in section 6.1. We decided that polygons are just so we're all on the same page. A closed shape with three or more, same as saying at least three or more straight sides. And if we have all of our angles kind of going out, so if our polygon looks like this, so all the angles go out, we call that a convex polygon. And if we have an angle that goes in, so if it looks like that, that would be a concave polygon. We don't use the terms a lot in this course, but I think they do show up here and there, convex and concave. What would we mean if we were talking about a regular polygon? What would we mean if we said a polygon is regular? I'll give you a hint. A square is a regular polygon. All the sides and angles. So all the sides and angles are congruent. So what would be a regular polygon that we have worked with so far? And what?
Equilateral
triangle, equilateral triangle. And equilateral, what does lateral mean? So when we say equilateral, what are we saying? All the sides. And equiangular, all the angles. Could a polygon be equiangular but not equilateral?
Yes.
Yes. What would be an example? A rectangle. Perfect example. All the angles are 90 degrees, but all the sides are not the same. All right. So what we're interested in first is what we call interior angles. And we've worked with interior angles of triangles before. They're just the angles that are inside. So if I have some kind of polygon, like so, just connect that up, fine. The angles inside, this is an interior angle. And what we want to do is come up with a way of deciding how many degrees the interior angle of any polygon is. So we're going to I want to go through a little kind of a demonstration so that we can think about how we come up with this formula. All right, so we good with everything we have here? Pretty basic, more or less stuff that we know already. All right, so I'm going to draw the shape. And I'm going to talk about the sides, triangles, and angles. We're going to make a little chart and try to come up with a formula. All right, there's our shape. What kind of shape is that?
Triangle.
Triangle. What does tri mean?
Sides.
Tri just means 3, right? So tri, 3 angle. How many sides? We just said 3 sides. How many triangles are there? 1. And if we add up all the interior angles in a triangle, what do we get? We get 3, and they add up to 180 degrees. So we're talking about the interior, all the interior angles together. All right, next shape. All right, what kind of I almost gave it away. What kind of shape is that?
Quadrilateral.
Quadrilateral. Quad means 4 and lateral means side. And we said it has 4 sides. Now the trick that we're going to use to come up with our formula is I'm going to go from one vertex and divide this into triangles. How many triangles do I have there? 2. Now, can we all agree that if I added up all the angles in this triangle and then added up all the angles in this triangle, I would end up with all the angles inside the quadrilateral? Yeah, because I wouldn't be leaving any piece off. If I have this and that makes up that whole big angle. Yeah? So if there are 2 triangles, what do all the angles add up to? 360, right? 180 and 180. All right, let's do one more. All right, so what kind of shape is that? Pentagon, right? 5, penta. And gon, the word, the root, gon, is come from, it has to do with angles. Gon is angle. All right, so we're going to divide this up also. So I'm going to go from just one vertex and divide this into triangles. If I go here, I just end up with that side, so we're done. All right, so pentagon, how many sides? 5. How many triangles did I divide it into? 3. So if I have 3 triangles, what are all the angles going to add up to? 5, 180 times 3, 540. All right, so let's see if we can see a pattern here. How are this number of sides related to how are the number of sides related to the number of triangles? How do I get from the number of sides to the number of triangles? From 3 to 1, 4 to 2, 5 to 3. What am I doing there? So to get from 3 to 1, what am I doing? Subtract 2. To get from 4 to 2, what am I doing? Subtract 2. 5 to 3. Subtract 2. And I have one triangle. I have 180 degrees. I have 2 triangles. I have 360 degrees. So what am I doing with the number of triangles to get the number of angles? Multiplying by 180, right? 1 times 180 is 180. 2 times 180 is 360. 3 times 180 is 540. What if we had what we call an n-gon? That just means n sides. How many triangles would it have? How are we getting from here to here? -2. So we have n minus 2 triangles, and it just has n sides for some number. N can be any number. Has n sides, so we have n minus 2 triangles. So to get all of the angles inside this n-gon, what would we do at the n minus 2? Multiply it by 180. So this is how we get our formula for the number of how many degrees are inside any polygon? We subtract 2 from the number of sides, because that's how many triangles we could divide it into, and multiply that by 180, and that will give us all the angles inside that polygon. Kind of nice. Said triangles are friendly shapes. A lot of times we divide things into triangles to help us out. All right, so we get our formula. Here's our formula. So the way we're going to write this is, let me go back here really quick. But questions on what we did here? I just wanted to show you where this formula comes from. It just comes from adding up the angles in triangles. All right, so the sum of the interior angles of any polygon, and we're talking about convex polygons, of any polygon is n minus 2 times 180 degrees, where n is the number of sides. And that n minus 2, there's our important formula there. And the n minus 2 comes from dividing the polygon into triangles. That's how many triangles we can divide it into. So that's our first formula. Important formula. We're going to use that a lot. All right. So sum. The key words that you'll see if we're talking about the sum of the interior angles. It would be all. Sum, all, together, total. Anything that's telling you that we have all of them together. Those are that's your hints that you're going to be using this formula. Now, what if we had a regular polygon? So all of the sides, all of the angles are the same. If we know what all of the angles add up to together, how would we figure out how many degrees one of the angles is? So if we plug in n, that would tell us all the angles together. How would we figure out what one of them was? Divide by
4.
the number of sides, right? Perfect. So for an equilateral triangle, we know that all the angles add up to 360. They all have to be the same. We divide by 3. All 3 of them have to be the same, and we get that they're 60. In a square, we know that all the angles add up to 360 degrees. We want to know what one of them is. We divide 360 by 4, because each of the 4 are exactly the same. So for a regular polygon, one interior angle measures n minus 2 times 180 degrees divided by n. And again, n is the number of sides. So this is our second important formula for today. This is the measure of one interior angle of a regular polygon. The top tells us what they all are together, and then we divide by the number of sides we have. All right, questions then? All right, let's look at a couple of examples with these interior angles, and then we'll talk about exterior angles. So the first one, sum of, first, before we go on, sum is asking us to do what? Add, we want them all together. And folks, computers, they need to go away, please. The sum of the interior angles of a Pentagon. So the sum tells us we want them all together. So our formula, the sum equals n minus 2 times 180. And here what's n? How many sides? 10 sides. This tells us how many sides. What's another name for a Pentagon? Decagon. Deca means 10. And the decimal system, deci, means tenth. Dividing everything into tenths. Anyway, so we plug that in. So the sum is 10 minus 2 times 180. We get 8 times 180. And that equals, when we plug that in our calculator and calculate, 1440. 1440 degrees would be the sum of the interior angles of a Pentagon. What if the question asked us for what if we had a regular Pentagon and we wanted one interior angle? What would we do?
You do 10 minus 2 times 180 and then divide that by 2.
By
the
number of sides. So we did 10 minus 2 times 180. We get 1440. And how many sides? 10. So that equals 144. Good. 144 degrees. So one interior angle of a Pentagon, a decagon, so one of these angles in here would be 144 degrees. Yes. You can only, that's exactly right, very good. We can only do this dividing thing if we have a regular polygon, because otherwise the angles could be all different ones.
We just plug that in for any shape.
We just need to know how many sides there are. All right, questions there? All right, let's take a look at another example that you might see using this idea. So I'm going to draw a shape here, and we need to figure something out about it. And we want to find x. Well, what kind of shape do we have here? Pentagon, right? So can we figure out what all the angles together add up to? Yeah. Do we remember how do we do that? The sum is 5 minus 2 times 180. 3 times 180, and what did that come out to? 540 degrees. Well, don't we know all of these angles except for one? Yeah? So what would we do to figure out the one missing? Add them all together, subtract from 540. So we have 105 plus 95. What's this one? Plus 90 plus 100. If I add all that up, I get 390. 540 minus 390 is 150 degrees. So x is 150 degrees. So this is just like we did with triangles. If we were missing one angle, we just figure out what all of them have to be together, and then we can subtract to find it out. Questions there? All right, this next example is a little trickier. It's kind of backwards, kind of working backwards. So the interior angle of a regular polygon is 108 degrees. How many sides does it have? All right, so let's look at these the keywords here. The interior angle. Is that all of them together or one of them? One. Do we have a formula for one interior angle? Of a regular polygon? N minus 2 times 180 over n. And we know the angle is 108 degrees. So that tells us that 108 equals n minus 2 times 180 over n. And we need to find n. So first thing I see this n in the denominator here. How do we deal with that? Multiply both sides by n. Perfect. And I'm going to multiply here. Those go away. Those cancel. So I get 108 n equals n minus 2 times 180. Now what do I do with these parentheses? Distribute. Very nice. So I'm going to distribute here. So 108 n equals 180 times n is 180 n minus 360. And now we know what to do with this, right? I'm going to subtract 180n. 108n minus 180n is 72n, and I get a minus 360. So I get a negative here and a negative here. Divide by negative 72, and n equals 5. So this regular polygon would be a pentagon. One interior angle in a pentagon is 105 degrees. All right, questions there? Okay. Now let's talk about exterior angles.
Can you go down for a second?
Sure. There we go. We need to go down here. This backwards problem, that's one that a lot of times it's not difficult, but you just have to get it set up right and remember the procedure, and you'll be fine. All right, we good? Okay. All right, exterior angles. We've talked about exterior angles of triangles. Let's draw what we're talking about with a polygon. So I'm just going to draw some polygon here. We get the exterior angles, we just extend the side out one direction there. So this angle here is an exterior angle. This angle here would be an exterior angle. This angle here is an exterior angle. This one's an exterior angle, and that one's an exterior angle. So if we have a 5-sided polygon, we have 5 exterior angles. Exterior angles are very nice. For any polygon, the sum of the exterior angles. Sum tells us all of them together. Is always 360 degrees. So that makes it nice and easy. The exterior angles, if we add them up, we always get 360 degrees. And I think about the exterior angles if I start walking, if I'm facing along this line, and I walk here, and I turn through the exterior angle, turn again, turn again, turn again, I end up facing back the same direction. So if I turn all the way around and end up facing back the same direction, how many degrees have I turned? 360. So that's kind of what's going on there. All right, so exterior angles are nice. And then for a regular polygon, all the angles are the same. One exterior angle, if all of them together are 360 degrees and all of them are the same, how would we figure out what one of them was? What do you think, baby? If all the exterior angles are 360 degrees and they're all the same, how would we figure out one of them? Divide by the number of sides. Perfect. Just like the other one. Just like the other one, we just divide by the number of sides. Is 360 degrees divided by n, where n equals the number of sides. So exterior angles are really friendly. Now let's look at something here. The interior angle is the one that I marked in blue. What do these two add up to? 180. The interior angles and exterior angles are supplementary. So sometimes, or often, it can be easier to find the exterior angle and then subtract from 180 to get the interior angle. The exterior and the interior are supplementary. All right, questions there? The nice thing about exterior angles, it doesn't matter how many sides the polygon has, all of them together always add to 360. To find one angle for a regular polygon, we just divide by the number of sides. All right, let's look at a couple of examples with this and then we're done. All right, the exterior angle is 30 degrees. How many sides? So it says the exterior angle. Is that one of them or all of them? One. The means one. So for a regular polygon, what was our formula for one exterior angle? Angle equals 360 divided by n. They're all together, they're 360 divided by n. Then we have the angle. 30 equals 360 divided by n. What do we do to solve this? Multiply by n, very good. So those cancel. 30n equals 360. Divide by 30 and n equals 12. So the exterior angle of a 12-gon is 30 degrees. Questions? All right, the last thing I want to do is make a little chart. This chart can be helpful for remembering how many angles are in a polygon. I also want to talk about their names. All right, so our first one, our easiest one. 3 sides on a triangle. Interior angle sum on a triangle? 180. What's our next polygon? Add one side? Quadrilateral. How many sides? 4. All the angles inside add up to 360. 5 sides. What's that polygon? Pentagon. And all those angles add up to, what was it? 540. 6 sides. What's that shape called? Hexagon. Hex means 6. And what would all the interior angles of a hexagon add up to? 720. What are we doing each time here? Adding 180. They go up by 180 each time. 7 sides. What's that one called? Septagon is acceptable. The pentagon, hexagon, they actually come from the Greek, and sept is Latin. So we call it a heptagon. Septagon is okay. Sept, what other word are we familiar with that has sept? September. What month is September? It's not the 7th month?
Yeah.
The 9th month? Do you know what happened? Do you know where the word for August, where that came from? Augustus Caesar. He decided to add some months to the calendar so he could name a month after himself. So that's why we have August is the 8th month, and September is not the 7th month. All right, how many angles? What would all the angles in a heptagon add up to? 900. 8 sides. What's that? Octagon. When I was in was that when I was in middle school, or right when I was first in high school, when Chuck Norris's movie The Octagon came out? That was like the most awesome movie. So how many? What would all the angles add up to in 1080? All right, and so the pattern here is every time we go up one side, we add 180 degrees to our interior angles. Do we know any other names of special polygons? We talked about one, decagon. Do we know what a 9-sided one would be called? What? What did you say? Almost nonagon. 9 sides is nonagon. 10 sides is decagon. 12 sides? We could call it a 12gon. Is 12 sides a dodecagon? Dodecagon. How about 20 sides? That one has a special name. Do you know? Starts with an I. Icosodon. Then other than that, we just call them 13 gons, 17 gons. But some of them will give special names. All right, questions? Okay. Homework. And in addition to the bookwork, the 6.1 dynamic activity. All right, there you go.